In this lecture, we're going to learn about some things you need to be careful about when overloading with reference parameters. Let's look at a simple example here. We have two functions. The name is sayMyName, and they are function overloads because they have the same name, but the parameters are different. The first one here is taking a const std string reference. The second one is taking a string parameter by value. So these are valid overloads, and if we compile our program with these two functions in, it is going to compile fine. The problem is going to show up if you call this function like you see here. We have an std string variable, and we're going to say sayMyName and pass in this variable here. The problem is these two overloads that we set up are valid candidates to call this function here. The compiler is going to be confused. It is going to give you a compiler error, and the compiler error is going to be basically saying that your call here is going to be ambiguous. Okay, so this is the first problem you need to be careful about. If you set up overloads using references like you see here, you're going to have to choose either of this function to let in your program if you want the call like this to work. The second problem I want you to be aware of is about implicit conversions with references. Here we have two functions. Again, the name is max and max. So these are two valid overloads because the parameter lists are different. The first one is going to take double parameters. The second one is going to take int reference parameters. Now, suppose you have these functions in place and you issue a call like this. You have two char variables a and b here, and you call your maximum function like this and pass in char parameters or char arguments. If you do this, you probably expect the int reference function to be called. But what is going to be called is the double version. And the reason is the int reference version isn't really a valid candidate to call when implicit conversions are involved. If you remember in the chapter on functions, I think we learned about implicit conversions with references, and we saw that temporaries were involved. And when temporaries are involved, non-reference parameters can't really be used with temporaries because the compiler is going to stop you from doing that. If you want a call like this to really work, you have to avoid temporaries in which the compiler is going to set up a temporary variable which is going to be of int and passing a reference to that temporary to the function when it is calling it. And again, to avoid these temporaries, for example, you can set up your own temporary variables and have a name for it and then pass that to the function. This is going to work because this is not a temporary. It is a variable which is stored somewhere and which has a name in your C++ program. This is going to work. Or you can change your parameters to be const. Because we have seen that const reference parameters work with temporaries without a problem, and this is going to solve your problem. Okay, now that you really are aware of these problems, let's head over to Visual Studio Code, play with this a little more, and really make this super clear. Okay, here we are in our working folder. The current project is overloading with reference parameters. We're going to grab our template files and put them in place. Let's do that. And we are going to open our folder here in Visual Studio Code by dragging and dropping here on top of Visual Studio Code. We're going to have our project opened. Let's close the pane here, and we're going to remove whatever we don't need from this file. And we are going to go down here and set up our two overloads. Let's do that. We have two functions. They are overloads. The name of the function is the same, but the difference is in the parameters that we pass here. At this point, if we try to compile this program, it is going to compile fine. Let's try and do that. We're going to build with GCC. You're going to see that the build is good. The problem is going to come when we try to call these functions here. Let's include our string library, and we're going to go down and set up an std string variable, std string, and we're going to call this name, why not? And we're going to initialize this with Doug, for example, or John, because we're going to be saying somebody's name. Let's say John. This is going to do. And then we're going to go down here and say my name, and we're going to pass in name. Okay, the moment we do this, we're going to get a squiggly line here. Why? Let's look at the problems tab here, and we're going to see the error saying more than one instance of overloaded function sayMyName matches the argument list. So the call we're doing here can really be served by multiple functions here, and the compiler is confused as to which one we want to be called. So we're going to get a compiler error if we try to even compile this program. Let's do that. We're going to use GCC. We're going to get a compiler error that really says the same thing. Call of overloaded say my name is ambiguous because we have two different functions that can really serve this call. Once we have a situation like this, we really have to choose between these two guys, and we have to take one out to get this to work. So you may either take out the one that takes a reference or take out the one that takes a string by value. That's going to be your choice. But the message here is that if you make a call like this and you have these two overloads in place, you're going to get a compiler error. Let's take out the one that takes a parameter by value just to show you that now it's going to work. So we're going to comment this guy out. And if we build again, the build is going to be good. Build finished successfully. And if we run our program, let's bring up a terminal. We're going to clear this so that we have some space. We're going to call Rooster, and it is going to say your name is John because this is going to call the reference overload here. Okay, so let's bring this back in because I want you to see something else. Let's suppose we don't use a direct variable like we are doing here, and we want to pass in a string literal. Let's pass John in here directly and see that we get the same compiler error. So if we do this, we see that we still have the same problem. Even if we try to compile, we're going to get the same problem. So let's do that. We're going to build with GCC. We're going to have the same error. Okay, let's go down and say call of overload say my name is ambiguous. The reason is the compiler can actually take this John string literal and create a temporary out of this guy here. The temporary is going to live somewhere in memory. And the temporary can either be served by this call here because the compiler can pass a reference to that temporary here, or it can copy that temporary in this second function here. So the call here is still ambiguous for this little guy here, the string literal that we are passing in here, and we have the same problem basically. Again, we can comment this guy out. And then the compiler is going to know that it is going to do an implicit conversion from a string literal to an std string. It is going to store the std string somewhere in memory, and it is going to pass a reference to that in this function here. And this is going to work because this is a const reference. If we try and take out this const here, we're going to get a compiler error, and you should know the reason why. Because temporaries don't work with non-const references. We have seen this at multiple occasions in the course, but let's just build to show you the error. And the error is going to be somewhat confusing, but now you know the error. But we're going to put in the const here, and you're going to see that this is going to work now. We're going to build with GCC. The build is good. We can clear and run Rooster. Now we see that our reference function here is called. Okay, this is the first thing I want you to be aware of when you have overloads that take references. They can really throw you off, but now that you know this, you're going to be careful about that. Let's take out this call here because it is problematic for the moment, and I want you to see a few other things. We are going to set up two other overloads. They are going to be of the max function here. The first one takes double parameters. The second one takes and references. Let's take out the second line here because I want you to see the one that takes non-const references. And things can be a little confusing with these two calls here. We're going to go down and set up two variables of car type. We're going to say A is 6, and we're going to say car B is a 9, for example. We don't need this guy here. And we're going to go down and say auto. We have two curly braces in here. Let's take them out. And we're going to go down and say auto result. And we're going to say equals max. And we're going to pass in A and B. Okay, now that we have this call set up here with these two variables as arguments, you can go on top here and try to guess which function is going to be called. At least if it was me and I was learning about C++, I would guess that a car type is really closer to an int than it is to a double because it is an integral type. and I would expect the function with int max here to be called. But the truth is, the double function here is going to be called, and we can build and run this program to prove that. Let's build and run, show you that the double one is going to be called. Then we're going to try and figure out why that is. If we run Rooster, we're going to see that double max was called. Why is that? Well, the compiler is going to look at the call we have here, and it's going to see that we are passing in car types. And it's going to search for candidate functions to call. It's going to see the first one takes double. It's going to see the second one takes int. And it is going to exactly think like you do. It's going to say int is closer to car, but if I try to transform my arguments here to int, I will need to do implicit conversions. And I know implicit conversions don't work well if I have a parameter passed by non-const reference. So if I do an implicit conversion and try to call this function here that takes int reference, I'm going to get a compiler error. So the compiler is basically going to discard this function here, and it is going to look at this one. Then the compiler is going to say, I am capable of transforming from car to double, and I can call this function here. And that's why we are getting this function here called, and we see double max called. We can go even further and really show that this is not a valid candidate for the call here by commenting out the double version here. We're going to get a compiler error because implicit conversions don't work with a function that takes parameters by non-const reference. If we do this, you see we have squiggly lines. And if we try to build this program, we're going to get weird compiler errors. But now you know the reason for these errors. And this is something I really wanted you to be aware of. Be very careful if you have functions that take non-const reference parameters and you are doing overloads like this. You have to make sure the overload that is called is the one you want to be called. So if we want the int reference one to be called, we really have a few options. The first option is to do the conversions ourselves. So for example, we can say int and say temp A, for example, and we're going to do an assignment from A here, and we're going to say int temp B, and we're going to do an assignment from car B here. Can we do this? We have squiggly lines, but let's do that. And we're going to pass temp A in here because now they are variables and they have an address in memory. They are not treated as temporaries by the compiler. Now let's try and figure out why we have this squiggly line here. Let's try and build. Now you see that the build is successful because we are explicitly transforming from car to int. And this is going to do the conversion because we are going through an assignment here. If we wanted, we could even do an explicit cast and say static cast and cast to int from our variable here. This is also going to work. And we're going to do the same here and say static cast and cast to int from our variable b here. And again, if we do this, we're going to compile file. Let's compile again. The compilation was successful. We can clear now and try to run the program. Now, because we have integer variables, this guy is going to be called because this is going to be the best match for the call we are doing here. And if we run Rooster, we're going to see that int ref was called. Int max was called here. And this is what we have here. This is the first option. The second option is to use const references. So we can take this out, what we just did, and turn these guys back to A and B here, and put const reference parameters in here. So we can comment out the first line here and comment the second one here. And this is going to do exactly what we want because now implicit conversions are going to be allowed if we have a const reference here. And again, if this doesn't make sense, please go back and watch the lecture on implicit conversions with references. I think it is in the chapter on functions. All these things are going to make sense. Make sure you really understand this. So if we build again, the build is going to go through. And now if we run, we're going to get the int max function called. Let's run Rooster and make sure of that. And we have this called here. This is really all we set out to do in this lecture, raising your awareness on a few problems that might come your way if you are trying to overload with references. We are going to stop here in this lecture. In the next one, we're going to learn about overloading with const parameters by value. Go ahead and finish up here and meet me there.